should be recording as soon as the little arrow, a little dot turns red. There we go. And can y'all see my screen?
Yes.
All right. So we talked about relative frequency, and like I told you, this is kind of like your project. This is, you know, you go back here, you get a pack of M&Ms, you open it, you sort out, and there's some people that sort their M&Ms and their Skittles before they eat them.
What?
Now, I do that with my gummy worms. I like the sour gummy worms, you know, the sour ones. You know, I don't know what you call them, but they have octopi, they have gummy worms, they have berry gummy worms. I like those. Anyway, I will sort them out before I eat them because I like the flavors of certain ones. Now, some people do that. I don't know why you would do that with plain M&Ms because they're all chocolate and they're not flavored. So I don't understand why you would do that with plain M&Ms. I think it's an OCD thing. But you separate the colors, and you don't. And this is what you're going to do in your project. You know, after you do all the counting and everything, you might want to make a couple of frequency tables. You know, and make your and bar charts, or you know, however you want to do it. You could do it in a pie chart with percentages, and do relative frequency. You can do that and draw a relative frequency. Now, I don't think many people do relative frequency bar charts, but that's not a big deal. You just need to know how to make it, and I'll show you that when we get into chapter 3. A Pareto chart. I want you to write down what a Pareto chart is. Do that for me, please. Why? Because a Pareto chart is something that's going to be on your standardized test. It's not used a lot, but what is it? It's when you put your boxes in a descending or ascending order. Okay, here's an example. Bars are put in this case, decreasing order. That's what you need to say. The Pareto chart, bars in descending order. That's all you need to write. And there it is. Bars in descending order. And it goes down. Now, I'm not going to say it's used a lot, but I will say that you could be asked that question on a standardized test. What is a Pareto chart? Or which of the following is a Pareto chart? And you're looking for order. You're looking for descending order.
I'm in class.
Okay?
No, he can say.
Oh, okay, never mind.
I'm not even listening. I just
Are
need
you at
water.
work, Miss Noble? Miss Noble, are you at work?
Oh, man.
Sounded like she was at work. All right, suppose we want to know side by side. You don't see side by side unless you have two sets of data. Write that down. Two sets of data with a side by side. Side by side, you usually have two or more sets of data. I don't test you on this, but you might be asked on a standardized test. I doubt it, because most of the time when you get into side-by-side bar graphs, you have already had a couple of probability and statistics courses. So, you know, that's really not a test question. You could make it a test question, but side-by-side graphs used with two or more sets of data. And here's an example. Marital status in 1990 versus 2006. The two sets of data is 1990 and 2006. So you would put them side by side on a bar graph, and that's what it would look like. Now, I'm not going to spend a lot of time on this. Like I said, it's probably not testable. It's probably not on my test. I I don't even think I have a question on my test about side by side. And I don't think you would be asked that on standardized test. And like I said, if you had 2 or 3 probability of statistics courses under your belt, then you would see it again. So I'm not going to spend a lot of time on that. Horizontal bars, this is just a preference. Tomato, tomato. You can do a vertical, side by side, or a horizontal. Some people like the horizontal because it's easier to read. So you could put, side by side, horizontal, easier to read for some people. It's a choice. I have put in reports, I have put 2 different graphs with the same data, and I will get some people to say, oh, I like the first one better. It's easier for them to read. And some people like the horizontal versus the vertical. That's just a choice. Now, make sure you write down a pie chart. Put a star beside pie chart and bar chart. I do test you on those 2 things, bar chart and a pie chart. Can somebody tell me what the requirement is for a pie chart? There's one requirement.
You have to make sure it's accurate to 100%.
It has to equal 100%.
It has to equal 100%, yes. So put that in red somewhere on your definition. The percentages have to equal 100%. If it doesn't, the pie chart is not valid. And you will be tested on that on a standardized test. They will test you on a pie chart itself, and they will test you on the validity of a pie chart. So you would have to add up the percentages to test the validity of a pie chart.
I have a quick question.
Yes, go ahead.
For the bar chart, do we just have to be able to read a bar chart, or do we have to be able to give a definition of a bar chart?
Right here, like I told you, I told you this, and I might have not have. Make sure you can add up the numbers. I'm trying to find a bar chart, but I guess we don't have one. And that relative frequency bar chart is not what I want, but let's see if that's it. Yeah. Okay, here is the test question right here. The test question will be like that. They'll just give you that, and they'll say, how many M&Ms are in the package? That's what they'll say.
Okay.
And you go, okay, 12 plus 10 is 22. 22 plus 9 is 31. 31 plus 6 is 37. 37 plus 3 is 40. And 40 plus 5 is 45. So there's 45 M&Ms in this package. Unless I made a mistake. Y'all check my math. But you need to be able, Mr. Michelle, you need to be able to read a bar chart. Okay?
Okay, thank you.
Uh-huh. And know the difference between a bar chart and a histogram, even though a histogram is pretty much a joke. But, the boxes touch each other with a histogram. Because a standardized test will ask you, is this a bar chart or a histogram? And they'll have one down there, and you answer accordingly. But they like to ask that question for some reason on standardized tests. Pie charts, where are we? Here we are. And there is the data. And you got to be able to what? You got to be able to find the total, because percentages, the relative frequency is what's on a pie chart. So you're going to have to add all these up and then divide each one by the total. And then that's what they did to get that. There is your pie chart. And you would have to check, you'd add them up. Let's see, 58 plus 6 is 64. 75 and 25 is 100. And that's what the first thing you would do on a pie chart is check your percentages. Do me a favor, somebody take a calculator and add up. Let's get an N. And I tell you what, do me a favor, and I want you to I want you to do a relative frequency column on this, I'm going to put it on just do a relative frequency for this, please. I can't, and this is qualitative. Why is it qualitative? Blondes, brunettes, and redheads. It's categories. Never married, married, widowed, and divorced. 55.3, 127.7, 13.9, and 22.8. I need somebody to add those up. I'm not going to do it, but I want somebody to add those up for me. And I need 2 people to confirm the same number before I put it down here. So somebody add those up.
I'm sorry, what did you get? 219.7.
I'm sorry.
219.7.
Okay, I heard 219.7 twice. All right, now I'm going to go to my handy dandy, and I'm just doing this. I'm doing this for 2 reasons. One reason I'm doing it is because I've got a couple of emails from people that still suck at, finding some things. So I thought I'd find the relative frequency here and kill 2 birds with 1 stone by, showing you the pie graph. So I'm kind of doing the relative frequency as a review for those that, suck at it. So relative frequency, I'm just going to write the fraction. Now, remember, the fraction needs 95%. 95% of the time, the relative frequency will be a decimal, and it will be rounded most of the time to the 100th. Okay, so remember that and read the directions when it talks about finding the relative frequency. Read the directions to make sure you round correctly. All right, so this would be 55.3, 127.7, 13.9, and 22.8. And then I take my red marker, and I'm just trying to emphasize the total right here. 219.7, 219.7, 219.7, 219.7. And you would put those fractions in the calculator and you would round it to the 100th. Okay, so somebody give me the first one, please. What is 55.3 divided by 219.7?
I got 25.2%.
Okay, 0.2. Give me 4 digits decimal wise.
Okay, that would be 25.1707.
Okay, 0.25170. So my directions.
I want you to bring your brother his phone.
The directions say round to the nearest 100th.
I have it here with me.
So that would be 0.25. Okay, so there is my answer right there, 25%. So that's what you would do for a test. Okay.
Yeah. Can I have it?
All right. Sure. Question. All right, that's basically what you would do for a pie chart. Okay. I'm not going to ask you to do that much more for a pie chart. Only check the validity. Make sure you check the validity of a pie chart.
Please.
We talked about relative frequency.
Hubert,
Yes.
can we do that again? It's 55.3 divided by 219.7.
Yeah. Hold on. Oops. That's not what I want. There we go. Yes. I did the first one for you. 55.3 divided by 219.7. On your calculator, it comes out to be 25170. Now, as I just told you, 95% of the time, they're going to ask you for a decimal and round to the hundredth. So 0.25170 rounds to 0.25. And on a pie chart, that would be 25%.
Okay.
And that's what you would do for each one of those, just to, put percentages in your pie chart if it asks that. Relative frequency is percentages, but most of the time they ask you on relative frequency, they ask you for decimals. For pie chart, percentages.
Okay, thank you.
Okay, yes, ma'am. All right, next. I'm not going to go over this because I just went over relative frequency once. I'm not going to go over it again. We've already been over it several times. I'm looking for something different to go over, so just bear with me a second. A histogram. Now, if you read that definition, and you don't have to read it, you don't have to write it. It's really a joke because the difference between a histogram and a bar chart touch each other on a histogram. And you can actually see that right there. That's it. That's the difference. The boxes actually touch each other. Now, if you give me a mathematical definition between the two, I'd like to see it because I've never seen one. The difference between a bar chart and a histogram, the boxes touch. Or the bars touch. That's it. And like I said before, sometimes I think a lot of statistic terminology is just stuff fabricated or made up just to make it sound important. A bar chart doesn't sound important. A histogram does. I'm not going to spend a lot of time on the difference between a bar chart and a histogram.
Mr. McClure.
Yes.
I looked it up and I put what the computer said on the chat.
What does it say? Please tell me.
The differences between histogram and bar graph can be drawn clearly on the following grounds. A histogram refers to a graphical representation that displays data by the way of bars to show the frequency of numerical data. A bar graph, however, is a pictorial representation of data that uses bars to compare different categories of data.
Okay, now tell me what the difference between them are.
I don't know.
There's no difference. But thank you for that. There's no difference between them. So I'm not going to spend a lot of time on them because you like bar charts because you don't like to see boxes touch each other. Okay? And if you like histograms, that means you don't like bars that don't touch each other because that's the difference between a histogram and a bar chart. I think it's ridiculous, but anyway. We already talked about classes means quantitative. There's one right there. And we talked about lower upper limits, class width. We talked about that, right?
Classes mean quantitative?
Yeah, quantitative right here. Finding the class width. We talked about
sir,
class
I don't believe
width,
we
correct?
talked about that.
I don't think we talked
No,
about
sir,
that.
I don't believe we did.
Okay, we're fixing to right now. All right, so I thought we did. Oh well. Let's talk about it. I'm gonna write we're gonna go here because I'm not gonna start with big numbers because it would confuse you. So we're gonna start with small numbers. I'm gonna give you a quantitative frequency distribution. And that is, let's go with age and frequency. And let's go with, and I'm going to try to expand this a little bit so I have plenty of room to write. So I'm going to go from 10 to 14, and from 15 to 19, and from 20 to 24, and from 25 to 29, and 30 to 34. And my frequency is 1, 3, 8, 2, and 1. Okay, now there are several things that you need to be able to do, and this is testable. This is, I'm going to test you on this and standardized test. You need to be able to do the following things with this quantitative frequency distribution. Remember, quantitative means mathematical. Okay, so that's why we haven't done it yet, because all those previous frequency distributions were what? Not quantitative, but what?
Qualitative.
Qualitative. All right, and you can't do, the only thing you can do with qualitative is find the relative frequency. But with quantitative frequency distributions, first you do n. You find n because you got to have n. You got to have the total. That's the first thing you do. Then you find the relative frequencies. So we're going to go ahead and do the first two things right now. So add a column and relative frequency. And I want everybody to do the relative frequency for those 5 numbers, 5 classes. Somebody give me the total for me. N is equal to what? 15?
15.
Okay, good job. So I'm going to take that, I'm going to highlight that for you. And you take the next minute and give me those 5 relative frequencies, and I want you to round to the nearest hundredth. TH, hundredth. Round to the nearest, round to the hundredth. So go ahead and do that. I'll give you a minute.
Gmail.
Okay, so the first one would be 1 over 33, or 1 over 15, 3 over 15, 8 over 15, 2 over 15, and 1 over 15. Now I need somebody to tell me what 1 over 15 gives me and round it to the nearest hundredth, please. And just say 0.02 or 0.03. Don't put a 0 in front of the decimal. Just say point blah, blah, blah. What is it?
0.06.
0.06.
I'm sorry, point what?
0.067.
0.08 or 0.07?
0.07.
Round to the nearest hundredth. Okay, somebody give me 3 over 15 and tell me for nearest hundredth. Point what?
0.2.
0.20. And somebody give me 8 over 15, please.
0.53.
And somebody give me 2 over 15, please.
0.13.
0.13.3.
And that is how you do the relative frequency on a test. Now, you don't have to write down the 1 over 15 and 3 over 15. You do that however you want to, but the answers that you punch in should be 0.07, 0.2, and so on. Now, I'm going to take my handy-dandy highlighter, and I'm going to highlight that 15 right here on each one of these. Kind of bring home the point that you divide by the total. And read the directions to make sure you round correctly. All right, so you know how to find those two. Now let's find the third thing. The class width. Now, before I find the class width, I want to show you, and I probably showed you this before. I can't remember what I've shown each of my 4 120s, so y'all have to bear with me. I'm going to take a yellow highlighter and a pink highlighter. You take whichever color you want. And I'm going to highlight this side of my classes. Now, I might have shown you this earlier. What is that side called? Anybody know? That's called lower class limit. Write that down. Lower class limit. Lower class limit. And then the pink, if the yellow is called the lower class limit, what do you think the pink is called?
Upper class limit.
Upper class limit. And I don't know if I got enough room to write that, but upper class limit. Okay, so the pink side is your upper class limits, and your yellow side is your lower class limit. Now, to find the class width, you take two corresponding upper class limits or lower class limits, and I want you to pick whichever one you want. I always pick these two right here. Now, you don't have to pick those two. If you're a rebel, you pick 34 and 29, or you pick 25 and 20. I always pick these two, and you subtract them. 15 minus 10. And that gives you a class width of 5. So you need to write that down so you know what to do. In order to find the class width, you find two corresponding lower class limits or upper class limits, and you subtract them. Now, the class width cannot be a negative, so you're going to always subtract them decently. In other words, the largest from the lowest from the largest. Somebody has a question, I believe, or somebody.
It's
Yes.
So what if your widths between like the ages are different? Like in my survey, I did the first.
They can't. They've got to be set up right. That's a good question. You have to set them up correctly. Each one of these has to be 5 from each other, and that's how you set it up. So 19 minus 14 is 5. 24 minus 19 is 5. You have to set them up accordingly. Is it going to cause your whole survey to go wacky? No, but it will cause some of your math to go wacky. Okay? All right, so that's how you find the class width. I always pick these two, so I'm going to take my highlighter, and I'm going to just highlight that in green. And I'm going to put right here, always subtract. Okay? You always subtract. And there's no negative class width, so it's always going to be positive. All right, so that's number 3. Number 4, you want to find your class boundaries. I'm going to put 4 out here because I'm going to need some room. Class boundaries. How do you find your class boundaries? Well, first of all, there's a rule, kind of like a rule that you have to follow before you do the class boundary. If you have whole numbers, your class boundary is going to be to the 10th. And usually they use 0.5. If your classes are to the 10ths, you're going to go to the 100th, which means 0.95. When you go to the 100th, then you're going to use the 1000th, and that will go to 0.995. And then the next one would be 0.9995 but you're not going to have to worry about that in here. These are whole numbers. These are whole numbers. All of these are whole numbers. 25, 29, 30, 34. So we're going to use the 10th, and we're going to put our class boundaries as the 10th. Now, somebody give me the whole number before 9. I meant before 10. I just gave it to you. 9. So my first class boundary is 9.5. Right here. What number comes before 10? 9. And then you add a 0.5 to it. And now you just add the class width. What's 9.5 plus 5? 14.5, Hubert. What's 14.5 plus 5? 19.5, Hubert. What's 19.5 plus 5? 24.5, Hubert. I appreciate y'all's interaction. Thank you. And 24.5 plus 5 is 29.5. And I'm going to add 1, and that's going to be 34.5. And I'm going to highlight that, because some books will ask you for the next class boundary. Some books will not. And that is this class boundary right there. What comes after 34? 34.5. So if you're doing a class boundary question, they're going to give you 1, 2, 3, 4, 5. You get to the 5th blank, and there's an extra blank out here. They're wanting that number that comes after the class boundary that's after 34, which would be 34.5. Sometimes a question will not ask that, and they just want the class boundaries that start right here before the number. What number comes before 20? 19.5. What number comes before 25? 24.5. What number comes before 30? 29.5. And that's what the class boundaries are. The number that comes before these numbers right here. I got the dot right here. That's what those represent. Now, again, how did I get them? Well, I asked myself, what whole number comes before 10? 9. And then I added that 0.5 to it. That's how you get the first number. And then you just add the class width, which is 5. So I added 5 to here, got 14. Added 5 here, got 19. Added 5 here, got 24, and so on. The class width, that's why the class width is so important. You've got to add the class width to everything. Class boundary and the midpoint. And that's the next. And I ran out of room. The midpoint. Number 5, the midpoint. I'm going to try to write it right here. Midpoint. Midpoints, because you got to do all of them. The midpoint, and I'm going to take these two numbers right here. I'm going to take my first ones right here. That's the way I do things. You don't have to. You can do it backwards and start from 30 and 34 and subtract. But I don't do that because that's extra work. That's stuff that you don't need to be doing. I'm going to highlight this. I'm running out of colors, so I'm going to use orange. I've already used orange. I've already used all my colors. I haven't used the other. Used green. Okay, I don't have any more colors, so I'm going to use silver. I love the Sharpie right here. Silver. I don't know if you'll be able to tell it, but there's silver. Okay, how do I find the silver, the midpoint? Well, I pick those two numbers right there, and I'm going to add them together and divide by 2. 10 plus 14 divided by 2. And what number does that give me? Well, 10 plus 14 is 24, and half of 24 is what? 12. So my first midpoint is 12, and then I add 5. What's 12 plus 5?
17.
And what's 17 plus 5? 22, Hubert. What's 22 plus 5? 27. And 27 plus 5?
32.
30. And that is my midpoints. Now, I just showed you on the midpoint and the class boundary. You got to find that first number. Once you find that first number, what do you add to it? You add the class boundary over and over and over. You got to find that first number. Now, what I would suggest you do when you go home, because I think class is just about over because we started at what, 10:10? I think we go to 11:05 or 11. Which one is it? Excuse me.
11:05.
Okay. And I would suggest, if you have never seen this before, I would suggest you go home tonight and you watch this video and you do the pause and stop and pause and stop, because you have to watch this and do it as I did it. And I know you're writing notes and you're not able to do that. So this is where the videos come in handy. For those people that have never seen this before, you need to watch the video tonight. And is there a law that says you can't watch the 103 videos and the 12010s and the 12011s? No. You can go in and watch them, and I'm doing the same thing. In fact, the best video to watch is 12010 and 12011, because those are, I spend a lot of time going over the frequency distributions. So, you know, if you want to, that's up to you. But this video that I'm doing tonight, doing right now, if you don't understand when you go home what I did in your notes, then you need to go over this video and you need to hit the pause button and follow it along and watch what I did. And I'll go over it again Friday because I'm going to have somebody, you know, ask or send me a question on frequency distributions. And you got to be able to find the total, the relative frequency. We did that here. The class width is 15 minus 10 is 5. That's why I highlighted it in green. And then class boundary, I got to find the first one. So what number comes before 10? 9. And you add a 0.5 to it, and you add the class width. And then the midpoint, 10 plus 14, I picked those two numbers right here in silver, 10 plus 14, and divide it by 2, and add the class width. Okay. So I would go home and study that. We are on, let's go ahead and put in the notes. We are on 2.2, slide number 37. Slide 37 on 2.2. And I'm going to cut off the recording. And I'm going to